Hello everyone, welcome to my Rashid Iqbal channel. In this video, we will learn a step-by-step method to calculate the correct size of a perforated cable tray based on the number and size of the cable. And also we will learn how to choose the appropriate thickness of the cable tray for your application. So basically, there are two main methods for laying cable on perforated tray. Number one, touching method, where cable are placed side by side without any spacing. Number 2, spaced method, where each cable is separated by a distance equal to its outer diameter. Let us start with the touching method. In this touching method, all the cables are laid side by side on the cable tray without any spacing between them. The outer surface of each cable is directly touching the adjacent cable. This method is commonly used because it saves space on the tray. Second one, the layout looks neat and compact. It reduces the overall width of the tray. Even though this method looks organized, but it has a serious drawback. That is poor heat dissipation. Actually, electrical cables generate heat when current flow through them. When cables are placed too close or touching, air cannot flow between them. As a result, the heat gets trapped and the temperature around the cable keep increasing. So this method is generally not recommended in practical installation, especially for power cable. So according to IEC standards, when cables are installed in group or touching each other, their current carrying capacity reduces due to mutual heating. In that case, you must apply a derating factor, which could reduce the cable performance by 20 to 40% or more, depending on the number of cables. For example, if your cable has designed to carry 100 ampere, after applying the derating factor, it might only be allowed to carry 70 to 80% safely. That means you may need to increase your cable size, which adds cost and weight. That's why touching method is not considered a best practice for most electrical design. We strongly recommend using the spacing method instead of touching method, especially when dealing with power load. Anyway, for learning purpose, let's still look at the calculation process for touching method. So for the touching method, step 1, we have to list the cable to be installed on the tray. Step 2, note the outer diameter that we call DE for each cable from the datasheet or from the catalog. Step 3, multiply the number of cables into the outer diameter of the cable to get the total occupied width. Then add 10 to 20% margin for breathing space and future additions. Step 5, choose the next higher standard tray width. So let's see one example so that it will be clear for you. We have 10 cable of 4 core 16 square mm, which outer diameter is 18 mm. Then the total width equal to number of cable into outer diameter, that is 10 multiplied by 18 equal to 180 mm. This is the total width of all cables. Now add 20% margin equal to 180, and the 20% is multiplied by 1.20. This is 20%. Total width is 216 mm. Now we have to find the cable tray which width is 216 mm. As you know, this 216 mm is not available. This is not a standard size. So we will choose the final tray width equal to 250 mm perforated tray. This is the exact size which is available in the market. Now for the flange height, also known as tray height, we need to consider the largest cable diameter. Since all cables have the same diameter of 18 mm, as it is mentioned above, we should choose a flange height greater than 18 mm. Let's add 20% extra height for ventilation purpose. So 18 mm multiplied by 1.2, this is 20%, equal to 21.6 mm. So the next standard flange height will be 50 mm, because 21.6 mm is not a standard height. So we will go with 50 mm flange height. So finally, cable tray selection will be 250 mm width by 50 mm height perforated cable tray. So this is the final selection of cable tray. But remember, due to grouping or this touching method, we need to apply derating factor, and if needed, upgrade your cable size to avoid overheating. We are using 16 square mm 4-core cable. Its rated current carrying capacity in open air is, we can check in the catalog. You can see here 4-core 60 mm square cable current capacity is 68 ampere. Now, if we install 10 such cable together using the touching method without spacing, then we must apply derating factor due to grouping, due to touching method. So the standard derating table or manufacturer catalog, again let's see here. For 10 group cables, it is not showing here, but we can take this value since the cable shows the value for 9 cable. As you can see here, we will use the same derating factor 0.73. This is for 9 cable. Then the formula become actual capacity equal to rated capacity multiplied by derating factor. This is the formula where we can substitute this value 68 ampere. This is the cable current carrying capacity multiplied by 0.73. This is the derating factor. It become 49.6 ampere. So what does it mean? Even though the cable is rated for 68 ampere, but when we install in a group of 10 touching each other, it can safely carry only 49.6 ampere. This is the safe current. So in case if your electrical load is more than 49.6 ampere, so you must upgrade to a higher cable size like 25 square mm or 35 square mm to carry the current safely without overheating. Now let's understand the spacing method, which is highly recommended for cable tray installation. In this method, we leave a gap between each power cable, which helps in proper heat dissipation, maintain the cable full current carrying capacity, and avoid derating. So in this method, we do not use a derating factor because we already keep space between cable to cable. So derating factor is not required here. So the question arises here, what is the spacing rule? Actually, there is no strict rule in IEC or NEC standard that says you must use the outer diameter of the cable for spacing. But as a best practice, many professionals follow these approaches. Suppose if DE is the diameter of both cable, then the gap we maintain between cable is equal to the higher size of cable diameter. So the gap between both cable is equal to DE, is the diameter of cable. And the gap between the first cable and the side wall of the cable tray, which we called flange, should be at least half the diameter of nearest cable. Or you can maintain at least 20 mm gap. Let's take an example. If both cable have a diameter 60 mm, then the spacing between them should be also 60 mm. The gap between the first cable and the cable flange should be half the diameter of the nearest cable, which is 30 mm. In addition, we keep around 20% extra space on the tray for future expansion. This 20% reserve space depends on your company design standard or project requirements. It depends on your requirement actually. In other case, if one cable has diameter of 60 mm and the other cable has a diameter, means outer diameter of 100 mm, then the gap between these two cables should be equal to the diameter of larger cable. That's mean we keep a gap of 100 mm between them. But what about earthing cable? Actually, earthing cables do not need spacing. We can lay next to the power cable because they carry no current during normal operation. It's carry only fault current for short duration. So heat buildup is minimal and spacing is not necessary. Let's go through a practical example. Here we have 4-core 300 square cable, that is 2 numbers. Now we need to find the diameter of this cable. Let me open this catalog. As you can see here, this is an armored cable. We are going to lay unarmored. So 4-core 300 square mm cable is 61 mm. You can see here, this is 61 mm. This is the outer diameter of this cable. So I will mention here Now we have to lay 4 core 70 square mm, that is 2 numbers, and its diameter will be, let me check again. Here you can see 4 core 70 square mm cable. Each cable diameter is 31.4. So let me write here 31.4. Same way, we have 4 core 50 square mm cable, 2 numbers, and its outer diameter of each cable is 27. I already taken from catalog, that is 27 mm. Now we have 2 numbers of single core earthing cable, that is 95 square mm, and its outer diameter is 15.7 mm. I taken from catalog. We have single core earthing cable, that is 35 square mm, 2 numbers, its outer diameter is 9.9 mm, and single core 25 square mm cable, we have 2 numbers, and its outer diameter is 8.8 mm. So this is the all cable what we have to install on the cable tray. So we have to find out the proper size of cable tray. So let's start arranging cable in the cable tray. We begin with 2 numbers of 4 core 300 square mm cables. Each cable has a diameter of 61 mm as we mentioned above. Since both cables are of the same size, so we will maintain a 61 mm gap between them, that is equal to the diameter of the cable. And first cable to the wall of cable tray, or we can say flange of the cable tray, gap is half of the cable diameter, that is 30.5. This is the half of 61 mm. Now we have 2 numbers of 4 core 70 square mm cable, and each with a diameter 31.4 mm. So since these will be placed next to the 300 square mm cable, we will maintain a 61 mm gap, because as per the standard practice, the spacing between 2 cables should be equal to the larger cable diameter of the 2. And in this case, 61 mm is the larger than 31.4 mm. So we will keep gap between these 2 cable is 61 mm. Now we will lay another 4 core 70 mm square cable beside an existing 70 mm square cable. Since both cable have the same diameter, so we will keep 31.4 mm gap between them. After that, we have to lay 4 core 50 square mm cable with a diameter of 27 mm. Since it's being placed next to the 70 mm square cable, so we will again maintain 31.4 mm gap, which is the larger of the 2 diameters. Next we lay one more 4 core 50 square mm cable next to the previous one. As both cable are of the same size, so we will maintain same diameter 27 mm gap here. Now let's arrange the earthing cable. As per standard practice, earthing cable can be laid close to the power cable, either touching or a minimal gap of 10 to 20 mm, depends on your client budget or depends on your design. So here I will maintain 10 mm gap between the power cable and the earthing cable. So we are using here 2 numbers of 95 square mm earthing cable, each with a diameter 15.7 mm. We have 2 numbers of 35 square mm earthing cable, each diameter is 9.9 mm. Then 2 numbers of 25 square mm earthing cable, each with a diameter of 8.8 mm. Now let's calculate the total combined diameter of the earthing cable first. So 15.7 plus 15.7, these all are the earthing cable. So the total width of this earthing cable is 68.8 mm. Now next we calculate the total required width for all cable including their space. So I will calculate this all values, 30.5 plus 61 plus 61. You can see here the plus 68.8. This is the total earthing value what we calculated above, equal to 560.9 mm. This means we required a minimum cable tray width of 560.9 mm. But this is not a standard size. So we will move to the next available standard size, which is 600 mm width. Now let's calculate the flange height, means the height wall of the cable tray. So the technique to find the flange height, we have to see the largest cable we are laying in cable tray is 4 core 300 square mm, which has diameter of 61 mm. To allow for ventilation and airflow, we can add 20% extra height. That is 61 multiplied by 1.20. This is 20%, equal to 73.2 mm. Since 73.2 mm is not a standard height, so we will select the next higher standard flange height, which is 100 mm. So the final cable tray size will be 600 mm width multiplied by 100 mm height, cable tray size. Now one more important thing, in this calculation we did not reserve 20% space for future expansion. So if your client has sufficient budget and is planning for future upgrades, you can consider this option. So I just make a calculation for 20% space for future expansion. So 20% of future expansion equal to 560.9 plus 20%. This 560 point, this is our requirement. This is total width of the cable with spacing plus 20% equal to 673 mm. So after adding 20%, it becomes 673 mm. So the standard tray width will be 750 mm because 673 is not a standard size. This is not available in the market. So we can go with the 750 mm size cable tray. So the final cable tray selection will be 750 by 100 mm. This is only if you consider 20% extra space, then you can go with 750 by 100 mm size of cable tray. Otherwise, I selected here 600 by 100 mm cable tray. I did not consider 20% extra for future purpose, for future use. So I selected here 600 by 100 mm. Now comes the most important part of the calculation, that is load and span length calculation. So let's start it. So first we have to calculate cable weight per meter. We will refer to the manufacturer datasheet to get the accurate cable weight. So I need to open again Catalogue. Friends, if you are enjoying this video, please subscribe to my channel. If you would like to support me financially, you can send a super thanks. It helps me create more such informative content for you. Alright, back to the calculation. So you can see here 4 core 300 square mm cable is 12.19 kg per meter. This is the cable weight. 12.19 kg per meter. And we have two numbers of cable. So the cable weight will be 12.19 multiplied by 2 equal to 24.38 kg per meter. And we have a 4 core 70 mm square cable and its weight is, let me check again, 4 core 70 square mm cable, the weight is 2.9 kg per meter. Let me write here. So we have two numbers of 4 core 70 mm square cable. So we will multiply by 2 equal to 5.8 kg per meter. We have a 4 core 50 mm square cable equal to 2.06 kg per meter. I already taken from Catalogue to save your time. So for two cables, multiply by 2, 4.12 kg per meter. Now for earthing cable, 95 mm square single core earthing, its weight is 0.96 kg per meter. We have a two cable, so it will become 1.92 kg per meter. Same way 35 mm square cable, 0.371 kg per meter. For two cable, it's become 0.742 kg per meter. And finally, we have a 25 square mm single core cable. Its weight is 0.278 kg per meter. And we have two numbers of this cable, so it becomes 0.556 kg per meter. Now we will calculate the total weight per meter. So we have to add these all values. After calculating of this all value, it's become 37.52 kg per meter. This is the total weight of the cable in kilogram per meter. Now we will select the cable tray that can support this weight. From the manufacturer catalog, we can see the load capacity. Since we have selected 600 mm wide tray with 100 mm flange height, so the next step is to check its load bearing capacity. Here you can see that this cable tray with 1 mm thickness and 100 mm flange height has a load capacity of 80.4 kilogram per meter. So this capacity of 80.4 kg per meter is more than enough to support our cable load, and our cable load was 37.52 kg per meter. So this selection is perfect. So the selected cable tray is 600 by 100 mm and the thickness of the cable tray is 1 mm. 1 mm is the thickness. So this is our final cable tray selection. Now finally we will calculate the span length, which means the distance between two supports. To find this, we must consider not only the weight of the cable but also the weight of cable tray itself. From the catalog, we can check the weight of cable tray. Now we have to check the cable tray weight. Here you can see 100 mm flange height with 1 mm thickness and 600 width cable tray. Its own weight is 6.02 kg per meter. This is cable tray weight without any cables. So the total load per meter is the sum of cable weight and cable tray weight. Here 37.52 kg for cable plus 6.02 kg for cable tray, which equal to 43.5 kg per meter. This is overall weight of the system in kg per meter. Now we go back to the cable tray catalog and refer to the load versus span graph. You can see here yellow line representing the 600 mm width cable tray. This yellow line you can see this is 600 mm what we selected earlier. In this graph on the y-axis we have a load in kg per meter and on x-axis, this x-axis, we have a span length in meter. So our load of about 43.5 kg per meter, the graph shows that you can see here 65 kg and just below this 65 kg you can see 1.5 meter. This is a span length, 1.5 meter span. This means we have a comfortable safety margin of around 20 to 25% extra capacity. But if your project load is higher, say around 140 kg per meter, then the span should be reduced to 1 meter. As you can see here, 140 load is here and just below this 140, you can see this is the 1 meter. So the 1 meter span length will be the safe length. So this was the method for perforated cable tray size calculation. I hope you find this video helpful. If you did, please don't forget to like and subscribe. See you in the next video.